Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain about the balancing of redox reactions. Okay, so what is a redox reaction? A redox reaction means the reaction in which both oxidation and reduction are going to occur, that is called a redox reaction. So redox reactions can be balanced by using two methods. The first method is half reaction method or ion electron method. The second method is what? Oxidation number method. Okay. So now let us discuss one by one method in detail to understand. So in this video I will cover half reaction method or ion electron method, and the next video I will cover oxidation number method. Okay. So now let us see the oxidation of reaction method or ion electron method. Okay. Come. So this is the, now we are going to see off reaction method or ion electron method. So in this method how we are going to do balance a redox reaction. So here first write the unbalanced chemical reaction in ionic form. So unbalanced chemical reaction we need to write in the ionic form. They will give the reaction, same reaction we will write in the ionic form, and write the oxidation numbers of each element in the reaction. We know how to find out the oxidation numbers. Okay. So write that oxidation numbers of each element in the reaction and identify the oxidation and reduction. So after writing the oxidation numbers, what we need to do? We need to write the oxidation numbers. Okay, we need to write the oxidation numbers. So after writing the oxidation numbers and separate the oxidation half and reduction half. Separate the oxidation half and reduction half. Oxidation half and reduction half. Separate the oxidation half and reduction half, balance them separately. So how to do what to do? Balance, we should balance them separately. Okay. Next, balance the atoms other than oxygen and hydrogen. Okay. So first what we need to do? Balance the other than oxygen and hydrogen. First, which means first we are not supposed to touch the hydrogen and oxygen. Then what we need to do? We need to balance the other than oxygen and hydrogen. So next, after balancing the other than oxygen and hydrogen atoms, first we need to balance the oxygen atoms. Okay, what we need to do? We need to balance the oxygen atoms by adding H2O in the deficient side. Whether the given medium is acidic medium or basic medium, no matter. How we are going to do balance? We balance by adding H2O in the deficient side. For which which atom? Oxygen atom. Means oxygen atoms are balanced by adding H2O in the deficient side. So irrespective of the medium. Next, balance the hydrogen atoms by adding H plus ions in acidic medium. Okay, in acidic medium how we are going to balance the hydrogen atoms? By adding H plus ions in deficient side. In basic medium add H2O in deficient side and equal number of OH minus ions in the opposite side. Equal number of OH minus ions we need to add in the opposite side. Next, balance the charges by adding the electrons. So how we need to balance the charges? By adding the electrons. Okay, electrons we will add. So this step I will explain while doing an example. Okay. Next, and equalize the number of electrons in both oxidation half and reduction half by multiplying with suitable numbers. By multiplying with suitable numbers, which means we need to balance the electrons. Oxidation half cell, some electrons are there. Reduction half cell, some electrons are there. Then what we need to do? We need to balance them. We need to balance them by multiplying with a suitable number and add the two half reactions like algebraic expressions. So algebraic expressions how will add, like that only you add the two reactions, you will get the balanced one. Okay. So these are the steps we need to follow. So this is all the theory. Now let's do one question. So by practice. So when you do the question by practice, these are all the steps you can remember in your mind yourself. Okay, right? So write the oxidation first. What is the first step? Write the unbalanced chemical reaction in the ionic form, and next write the oxidation number of each element in the reaction. Next, identify the oxidation number and oxidation and reduction and separate them. Separate the oxidation half and reduction half, balance them separately. Next, while balancing, first balance other than oxygen and hydrogen, and after balancing other than oxygen and hydrogen, first balance the oxygen by adding water molecules in deficient side. Next, balancing of hydrogen. In acidic medium, add H plus ions in deficient side. In basic medium, add H2O in deficient side. In opposite side, we add OH minus, equal number. Next, balance the charges by adding the electrons. Next, equalize the number of electrons in both side by multiplying with suitable number. Then after add the two equations like algebraic expressions. Okay, this is what, these are the steps we need to follow in the ion electron method. Okay, so now let us see one example for this. Okay, when you do the example, these all the steps will become easy for us. Okay. Now let us take the Fe plus 2 plus Cr2O7 minus 2, H plus indicates it is in the acidic medium, and Fe plus 3 and Cr plus 3. Okay. So now here Fe plus 2 to Fe plus 3, Fe plus 2 to Fe plus 3. So increase in oxidation number, this is oxidation, and here chromium plus 3 to, chromium to chromium plus 3, obviously here it will become, it is the chromium plus 6 here, chromium plus 3, it is the reduction, it is the reduction. Okay. So how you got plus 6 here means just simply by calculating. Okay, see here Cr2O7 minus 2, Cr2O7 minus 2, what is the chromium oxidation number? Simply you consider it as the X. Okay, 2x plus 7 into minus 2. So here oxygen oxidation number is minus 2, that is equal to charge of the molecule is minus 2, equal to minus 2. Okay. So now 2x 7 into minus 2, that is minus 14, that is equal to minus 2. Therefore 2x is equal to minus 2 plus 14, therefore 2x is equal to plus 12, that is therefore x is equal to plus 12 by 2, that is equal to plus 6. So plus 6 is the oxidation number of chromium, that is plus 6 to plus 3 means obviously that is reduction. Okay, now what we need to do, we need to separate oxidation half and reduction half. Okay, so oxidation, this is the oxidation half and reduction half, oxidation half and reduction half. Okay, oxidation half and reduction half. So what is oxidation half? Fe plus 2 is gives rise to Fe plus 3, this is the oxidation half. Next, reduction half, Cr2O7 minus 2 is gives rise to Cr plus 3, this is the reduction half. Okay. So now in oxidation half and reduction half we separated. Now what we need to do? Balance other than oxygen and hydrogen. What we need to do, children? Balance other than oxygen and hydrogen. So here there is, here only one iron atom is there, here also one iron atom is there, no need to balance. Okay. So Fe plus 3 to Fe plus 2 to Fe plus 3, Fe plus 2, Fe plus 2 to Fe plus 3, iron plus 3. Okay. But here two chromium atoms are there, here only one chromium atom is there. So what you need to do here? Cr2O7 minus 2 gives rise to 2Cr plus 3, 2Cr plus 3. Okay. Next, Next step is what? Balance oxygen atoms. Balance oxygen atoms. Here there is no oxygen atoms, as it is we are going to write Fe plus 2 gives rise to Fe plus 3, and here see, here 7 oxygen atoms are there, here no oxygen atoms are there. How we balance the oxygen atoms? By adding water molecules, So Cr2O7 minus 2 gives rise to 2Cr plus 3 plus 7H2O okay. So oxygens are balanced. Next step is balance hydrogens. Here no hydrogens are there, as it is you write no hydrogens are there, plus 2 to plus 3 okay. Next here 14 hydrogens are there, here no hydrogens are there. So now it is occurring in the acidic medium. In acidic medium, how we will do balance? By adding H plus ions, at the deficient side. So Cr2O7 minus 2 plus 14H plus gives rise to 2Cr plus 3 plus 7H2O okay. So hydrogens are also balanced. Next step is balance the charges. We need to do balance. See here children, plus 2 is there, 1 into plus 2 plus 2, here 1 into plus 3 plus 3. So now here plus 2 and here plus 3 is there okay. So here we cannot increase positive charge, but we can decrease the positive charge. How we can decrease the positive charge? By adding electron. 1 electron you add. If you add 1 electron means this plus 3 will become plus 2. So you remember one thing in mind, we cannot increase the positive charge, but we can decrease the positive charge by adding electrons. Here more positive charge is there, decrease. How much it should decrease? 1 charge should decrease. For that we are adding 1 electron. So now here this is plus 2 and this is also will become what? Plus 2. Charge is balanced okay. Charge is balanced now. Next okay, here come this side. So here 1 into minus 2 plus 14 into plus 1 plus 14, that is equal to plus 12. So here what is the charge? Here plus 12 is there, and here 2 3 is a 6, plus 6 is there. So now here which side more positive charge is there? This side more positive charge is there. This we should decrease up to plus 6. So what I can do? You add 6 electrons. Add 6 electrons okay. So it will become plus 6. So plus 6 plus 6. Charges are balanced now. Next, equalize the number of electrons in both oxidation half reaction and reduction half reaction. For that purpose, simply what you do here, what is the number of electrons? 6 is there. You multiply this oxidation half reaction with the 6. Here how many electrons are there? Only 1 electron is there. So you multiply this reaction with the 1, so that the electrons automatically get balanced okay. Right. So now 6Fe plus 2 gives rise to 6Fe plus 3, and here 1 electron is there. 6 into 1 electron, 6 electrons okay. And in this one, so with 1 we are going to multiply, means there is no change here. So what we will get here? Cr2O7 okay. Thought okay. Cr2O7 minus 2 plus 14H plus okay, 14H plus 6 electrons here we are added now. 6 electrons gives rise to 2Cr plus 3 plus 7H2O okay. 2Cr plus 3, 7H2O. Now here we are having this is the oxidation half reaction and reduction half reaction. The both reactions what we need to do now children, we need to add them like a algebraic expressions. Okay, add them. 6 Fe plus 2 gives rise to 6 Fe plus 3 plus 6 electrons. Next, in this side, Cr2O7 minus 2 plus 14H plus 6 electrons is gives rise to 2Cr plus 3 plus 7H2O. 2Cr plus 3 plus 7H2O. So now here, if here this side, left side is 6 electrons are there, right side also 6 electrons are there. Okay, so get cancel out. And next, here still anything are there to cancel out like that? No, nothing is there. So write Cr2O7 minus 2 plus 6 Fe plus 2 plus 14H plus, okay, completed everything, is gives rise to 6 Fe plus 3, 6 Fe plus 3 plus 2 Cr plus 3, 2 Cr plus 3 plus 7H2O. So this is the balanced reaction. Okay, this is the balanced one. Okay, in this balanced one, let us see whether the atoms are balanced or not. Okay, so chromium, 2 chromiums balanced. Next, irons, 6 iron balanced. Next, oxygen, 7 oxygens balanced. Next, hydrogens, 14 hydrogens balanced. Next, charges minus 2 plus 6 into plus 2 minus 2 plus 12 plus 14. Okay, total 24 plus 24 is here, and here how much is there? See, 6 into plus 3 plus 18 and 2 3 is 6 plus 6, and here also 24. Here charges also balanced, atoms are also balanced. Now it is finally a balanced chemical reaction. Okay, so this is the way of balancing of this chemical reaction. Okay, it's the way of balancing. Okay, right. So, right, this is the way of balancing of a redox reaction. Okay, right. Okay, next let us take one more example for the basic medium. It is in the acidic medium. Next let us take in the basic medium. Okay, so basic medium, what is the basic medium they have given? Okay, consider like this. So MnO4 minus plus I minus is gives rise to MnO2 plus I2. This is the reaction they have given in the basic medium. So now how to do this in basic medium? So only one step is different, that is balancing of hydrogen only is different, remaining all steps are same only. Okay, so first identify their oxidation numbers. So here MnO4 minus they have given, here MnO2 they have given. So in MnO4 minus, what is the oxidation number of manganese? X you consider. So X plus 4 into minus 2, that is equal to minus 1. So here oxygen oxidation number is minus 1, total molecule is having minus 1 charge, that is equal to minus 1. Okay, so therefore X 4 into minus 2 minus 8, that is equal to minus 1. Therefore X is equal to plus 7. X is equal to plus 7 means here manganese oxidation number is plus 7, and in MnO2, so here manganese X, only one manganese is there, X plus 2 into minus 2, as it is neutral molecule, that is equal to 0. Okay, so therefore X 2 into minus 2 minus 4, that equal to 0, that implies X is equal to plus 4, means Here manganese oxidation number is what, children? Plus 4. Okay. So plus 7 to plus 4, this is reduction. Decrease in oxidation number, it is the reduction. Next, minus, here 0 it is. Why? Because in molecule of element, minus 1 to 0, it is the oxidation. Increase in oxidation number, this is the oxidation. Okay, oxidation and reduction. Okay, now separate. First oxidation you write, oxidation half cell or oxidation half reaction. Oxidation half reaction and reduction half reaction. Reduction half reaction, you see. So what is oxidation half reaction here? I minus is gives rise to I2. I minus is gives rise to I2. Reduction is what? MnO4 minus is gives rise to MnO2. So next step is balance the other than oxygen and hydrogen. Balance the other than oxygen and hydrogen. So here first, here only one iodine is there, here two iodines are there. So 2I minus 1 is gives rise to I2. Okay, iodine is balanced here. Next, in the reduction also, here manganese is there, manganese. So only one manganese is there. No need to do anything here. MnO2. Okay. Next step is balance the oxygen atoms. Here what is the next step? Balance the oxygen atoms. Here no oxygens are there. As it is you write, 2I minus 1 is gives rise to I2. And in MnO4 minus, here 4 oxygens are there, here only 2 oxygens are there. So in deficient side, what we need to do, children? We need to add water molecules. Okay. So MnO4 minus is gives rise to MnO2 plus 2H2O plus 2H2O. Okay, right. Next step is balancing of hydrogens. Here no hydrogens are there, so write the same. 2 iodine minus is gives rise to I2. Next, here 4 hydrogens are there, here no hydrogens are there. So here MnO4 minus plus 4H2O plus 4H2O is gives rise to MnO2 plus 2H2O plus 4OH minus ions. So this is the way of balancing of hydrogen ions in the water molecule or hydrogen atoms in the basic medium. Balancing of hydrogen atoms in the basic medium. How we balanced here? See, in these 4 hydrogens are there, there is no hydrogens. So here how we are balancing the hydrogen atoms? By adding H2O molecules in the deficient side, in opposite side OH minus ions. Here how many water molecules we are adding? The same number of OH minus ions we need to add in the opposite side. So now hydrogens also balanced, oxygens also balanced. But here see, here 2H2O is there, here 4H2O is there. Just you cancel out them. What you will get? MnO4 minus plus 2H2O is gives rise to MnO2 plus 4OH minus. Okay. So now also they are balanced. Here 2 water molecules are there, here 4 water molecules are there. So from these 2 water molecules I am removing, here 2 water molecules I am removing. So we are getting the balanced one. Next step is what, children? Balance the charges. Charges we need to balance. So here 2 into minus 1, here minus 2 is there, here 0 is there. So here that's why here 0 means you should still reduce the charge. How much reduce means 2 units we need to reduce. So what I am doing, plus 2 electrons I am adding. So here also it will become now minus 2. And here come, here minus 1 is there, here minus 4 is there. So what you need to do here? We need to balance the charges. How to balance here? Minus 4. Still reduce. How much reduce? 3 units to reduce. So 3 electrons you add here. Next step is what? Equalize the number of electrons in both oxidation half reaction and reduction half reaction. Okay, so here 3 is there, na 3 electrons are there. This total equation you multiply with the 3, and this total equation you multiply with the here 2 electrons are with 2 you multiply. Okay, so now what you get here, 3 to the 6 iodine minus 6 I minus is gives rise to 6 I2 plus 3 to the, sorry, here 3 with 3 we are multiplying, not with 6. Okay, 3 ones are 3 I2 and 3 to the 6 electrons. Okay, so this is the oxidation half reaction, and with 2 here we are going to multiply. So with 2 MnO4 minus plus 2 2s are 4H2O plus 2 3s are plus 6 electrons is gives rise to 2 MnO2 plus 2 4s are 8 plus 8 OH minus ions. Okay, so these are the balancing of electrons also, or means equalizing the number of electrons in both oxidation and reduction half. Next, what we need to do, simply you just add the two reactions, two half reactions you add, you will get the final balanced reaction. Okay, so let's add this. So when you add, how you will get 6I minus is gives rise to 3I2 plus 6 electrons. Okay, next 2 MnO4 minus plus 4H2O plus 6 electrons is gives rise to 2 MnO2 plus 8 OH minus. Okay, so now when you add them, you will get a balanced reaction now, like algebraic expressions. So at this side, left side 6 electrons, right side 6 electrons, you get cancelled. Next, here remaining all things you add simply 2 MnO4 minus plus 4H2O plus 6I minus. Students, the answer remained? No. 6I minus is gives rise to 2 MnO2 plus 3I2 plus 8 OH minus. Okay, so this is the balanced reaction in the basic medium. Okay, so now I explained you both a balancing of a redox reaction by using ion electron method or half reaction method, both in acidic medium and basic medium. Okay, so you try yourself by taking few reactions. If you are not getting, once again you watch my video, and wherever you are struggling, you just verify there, then you can get correct way of balancing. So these type of reactions 1 or 2 times, after practicing of 1 or 2 times only, you can get clarity. Without practicing, without getting a feel on the balancing, you cannot understand, you cannot get into the mind. Okay, what are the steps I explained? Once again slowly you watch and you can get full clarity. Okay, thank you for watching.